Hello, Chem students. Well, as the emoji indicates, this is the last video of the year. I know you're sad, but this is the last video of the year where we're going to talk about what acid and base solutions are and some unique properties of acids and bases. In the last week, we've spent a lot of time all over the place talking from classification of matter, separation of mixtures, solutions, solubility, phase changes, and now we're going to address acids and base solutions, a unique type of solution, the acid and base solutions. So let's get to it. So our objectives today are to recognize physical and chemical properties of acids and bases, and then to talk about the pH ranges and what they mean and how can we utilize them. In Chem 2, if you come to Chem 2 next year or the year after, we will spend a lot of time digesting what the pH scale means, how it works, mathematically determine how that all comes together. But today we're just going to address a little bit about the ranges and how indicators can change during the phase changes. So, properties of acids. First thing, they conduct electricity. They have ions. Acids are ions. Acids are charged particles. So since they are charged particles, you zap it with electricity. The charged particles are going to carry the electricity and it's going to conduct electricity. Second thing they do is acids neutralize bases. So if I take an acid like HCl and react it with a base like sodium hydroxide, they're going to neutralize one another. That means if something is really acidic and you mix it with something that's very basic, they're opposites of one another. They're going to neutralize or come somewhere in the middle, making just salt and water. And that salt does not have to be sodium chloride. It can be any salt. A salt is any ionic compound. Acids are sour. Think grapefruits, think lemons. Those are sour. Sour Patch Kids are sour. That taste is sour. And if they touch your skin, they have a burning sensation or they feel prickly. I always know if I'm setting up a lab and I get a little on me and it's not much, I start to itch. My forearms and my hands itch, and I realize I need to rinse my hands off because I've got a little speck or two of acid on me. That burns, or in really, really low concentrations, it'll itch really bad. Acids have pHs less than 7. So if you're looking at the pH scale, low numbers are the acids. So look at these things. You've got beer, you got orange juice, vinegar, egg yolks, milk. Milk is a little on the, just slightly because of lactic acid on the acidic side, but not much. Lemon juice, battery acid. Look, you even have pHs down here at -1. But yes, you can have pHs are very, very low. Low numbers are acids. Neutral, pure water has a pH of 7. If it has an equal number of acid particles and base particles, it's going to have a neutral, middle of the road value, a pH of 7. And then bases, they also conduct electricity because they also are ionic compounds. They also will do the neutralization, it's just backwards. So in this case, the magnesium hydroxide, which is found in milk of magnesia, will react with the hydrochloric acid to neutralize. Again, an acid and base will work against one another to make a salt and a water. Here the salt is magnesium chloride, not sodium chloride. Anything that happens to be an ionic compound can be considered a salt as long as it's not an acid or a base. Okay, so they taste bitter. When I think of bitter, I think soap, I think parsley, I think horseradish. They mention here sweetened cocoa versus unsweetened cocoa. My great-grandmother used to make these really, really awesome candies around Easter time. And you really wanted to go to Grandma Dressler's to get the candies because they were amazing. However, because she used inside the thing, it was like a coconut egg type thing. Because the inside was so sweet, she would make them both sweetened and unsweetened. And you knew when you got the one that wasn't sweetened, that cocoa in the middle was not sweet enough to counterbalance how bitter the unsweetened chocolate was. But some of the family members really liked that version, so that's why that was there. When they come in contact with your skin, they feel slippery. It's like you have soap on your hands. Okay, it feels like you have soap on your hands. They have pHs that are big numbers, the larger numbers greater than 7. So here's some things like seawater and baking soda and ammonia, bleach, milk of magnesia, which was mentioned in one of the examples. They all are very are basic, they have high numbers on the pH scale. So if you're thinking in terms of acids, acids go from 1 to just below 7. Bases are basically in the 7.1 and up, and neutral is exactly 7. So what's an indicator? Well, if I were to say something was an indicator in general, it just means it tells me about something. Well, an acid-base indicator tells me whether or not something's an acid or a base. It changes color at a certain pH. So when trying to figure out something's acidic or basic, you can use an indicator and add something to it and see whether it turns color. Now, I've intentionally used the two colors red and blue here because one of the most classic examples of an indicator is litmus. Litmus paper turns red with its acid and blue if it's base. So red litmus, you take a piece of red litmus paper and you touch it to some acid, it stays red. If you touch it to some base, it turns blue. So here's red litmus paper. Touching some base, it turns blue. Vice versa, if you take blue litmus paper and you touch it to a piece of acid, it turns red, goes back to red. So it's in between, but the paper is colored just slightly on one side or the other, so you can actually see a color change. Phenol, this is actually phenolphthalein. Phenolphthalein goes from being clear to pink. Goes from clear to pink, so you can really tell when it's a base, it turns pink. Bromothymol blue goes from yellow to blue. So bromothymol blue, if it's in an acid solution, it turns yellow. If it stays the same, it's blue. It's bromothymol blue. Cabbage, it's kind of cool. Red cabbage, you probably see them in the grocery store. If you take that red cabbage and you chop it up or just even put it into boiling water, the water will turn like this purplish red color. But if it put that into an acid solution, it's going to turn red, or on the red, yellow, orange side of the spectrum. And you put it into something basic, that depending on how basic it is, it's going to go from being purple to blue to green, depending on how intense the color is, how intense the basic nature is. There's a material called universal indicator. You can see here that you can literally, with one solution, it's a mixture of indicators. You can get a good idea what a pH is based on what color the solution gives you. Here's another visual of a universal indicator in different solutions. You can see that same stuff added to various test tubes of different pHs, changes different colors. And you can use pH paper, okay, where you dip it and it changes colors, kind of like universal indicator on a piece of paper. Or the probably most common way to do it is with a pH probe, where you literally put the probe into the liquid and it will tell you what the pH is straight up. We just give you a value. If we were in school, or next year when you come back, sooner or later you will be using pH probes, and we'll be using the Vernier LabQuest and the pH probes to determine the pH of different solutions. pH probe is going to give you a better number. Notice that all the numbers were whole numbers for almost everything we saw as far as the universal indicator and the pH paper, but the probe is going to give a much, much better value, going to give a closer number that we can actually do something with other than saying it's acidic or basic. And with that, we are done. So you have survived the last video of listening to me during the coronavirus pandemic. I can't say I am extremely happy for these to be done. I actually enjoy teaching. I wish I saw you guys more, but this is the best way we can do it under our current sets and conditions. So, one last time, be safe, be healthy, practice that social distancing. The virus, as of the taping of this video, is not dead. Caution is the #1 word to use. Wear those masks while you're out in public. Let's keep the spread down so that we can possibly see each other again in the fall. With that being said, I can't say I'll see you on the next one, because I won't, unless the next one is next year in Chem 2. You guys have a great, great, great year. I will see you later. Toodles.